Okay, now let's looking at some examples of how to use the integral test to determine whether something is convergent or divergent series. So here the first one we have is a summation n equal to 1 to infinity of 1 over n cubed. So we can see that this function, so let f of x equal to 1 over x cubed. So we can see that this function is continuous, 1 over x cubed. This is a rational function, is decreasing because it is a fraction 1 over. So the bigger the x, the smaller the overall value is. And also, the last one, f of n equal to an, like it's pretty much the same. So this is the one we can use to find the integral. We're going to use integral from 1 to infinity. This is the n of 1 over x cubed dx. Because this is infinity, so what we're going to do is we're actually going to have the limit first. And integral from 1 to n, 1 over x cubed dx. And this portion, we know how to find its antiderivative using the power rule or the reverse direction of the power rule. So we still have the n portions. 1 over x cubed, or x to the negative third power, which is equal to 1 over 2x squared. And we're going to evaluate it from 1 to n. Before taking the limit, let's evaluate it. We got negative 1 over 2n squared minus 1 over, minus a negative plus 1 over 2 to the 1 square, which is just 2. And then we can take the limit. The limit as n goes to infinity of 1 over n squared is going to equal to 0. So this one will end up with 1/2. So because it's 1/2, that means this is actual number. So this whole thing, the integral, can be evaluated as a single number. It is not infinity or negative infinity. That means this one is convergent. So the integral converges. And so the series is also converges. Okay, so again, one note. This integral, after evaluating them, we got 1/2. This number tells me that this integral converges. However, this is not equal to the actual sum value of this summation 1 over n cubed. So this one, make sure that they are not equal to each other. Now let's look at another problem. Summation n equal to 1 to infinity of 1 over square root of 2n minus 1. For this one, it is a continuous function. This is a 1 over square root. In the domain, it is continuous. However, the domain is not going to be a real number. It is decreasing because of 1 over. Still the same thing. The bigger the denominator, the smaller the whole thing. So we're going to let f of x equals to 1 over square root of 2x minus 1. And we're going to looking at the integral from 1 to infinity of 1 over square root of 2x minus 1 dx. We're going to take the limit as to b goes to infinity of integral 1 over 1 to b 1 over square root of 2x minus 1 dx. You can choose any number, any letter here. It is a way to notice that this is not going to be infinity anymore. And we can using the u substitutions. So this is going to be negative 1/2 power. After the antiderivative, the power rule, we will end up with square root of 2x minus 1, and then we're going to evaluate it from 1 to b, which is going to be square root of 2b minus 1 minus 1. And square root of 2b minus 1 is actually going to go to infinity. So this one is going to be infinity. That means the integral 1 to infinity 1 over square root of 2x minus 1 dx is diverge. And so the theory is diverged too.